Hello everyone. Today we want to find the gradient vector of a function in the form of 2y e to the power of 5x minus 2x cubed e to the power of minus 3z times y. Okay, so let's start. So we should know that the gradient vector is a vector in this form if function f is a function of x, y, and z, then the gradient vector, or del f, would be the partial derivative of f with respect to x, the partial derivative of f with respect to y, and finally the partial derivative of f with respect to z. So it's going to be a vector with its first component being the partial derivative of the function with respect to x, the second component of the vector being the partial derivative of f with respect to y, and finally the third component being the partial derivative of f with respect to z. So let's start with the first one. So the partial derivative of f with respect to x, when we want to take a derivative from f with respect to x, we have to consider the other variables to be constant. I'm going to rewrite f again. So it's f is going to be 2y e to the power of 5x minus 2x cubed e to the power of minus 3z times y. So when I want to take a derivative with respect to x, I have to take the other variables, which here are y and z. I have to take them as constant, so I'm going to write 2y, and then here e is a function, e to the power of 5x is a function of x. So, and you know what is the derivative of this type of function? It's going to be 5 e to the power of 5x, and for in the second term, this part is the constant part, or as we said, we take the variables to be constant, so it's going to be minus 2 e to the power of minus 3z y, and for x cubed it's going to be 3x squared. That is the derivative of x cubed with respect to x. And if I want to simplify this expression, it would be 10y e to the power of 5x minus 6y x squared e to the power of minus 3z. Okay, so with this being done, we go to the second part. So partial derivative of f with respect to y is going to be, so I write the constant parts. As we said, this part, which is not a function of y, we are gonna consider that to be constant, so it's gonna be 2e to the power of 5x, and finally the derivative of y is simply 1, and this whole part here in this term is gonna be constant when we consider y to be the only variable, so it's gonna be minus 2x cubed e to the power of minus 3z, and the derivative of y is gonna be simply 1. And finally, for the last part, so the partial derivative of f with respect to z, again I'm gonna only consider z to be the variable. In the first term I don't have any z, so the derivative of that term is gonna be 0, and in the second part I'm gonna write the constant parts, which is minus 2x cubed y and minus 3 e to the power of minus 3z. If I simplify this expression, I will have 6x cubed y e to the power of minus 3z, and for the previous part I will have 2e to the power of 5x minus 2x cubed e to the power of minus 3z. I'm going to continue this in the next page. Okay, so the only part that remains here is simply to substitute these expressions inside this vector. And finally, for the partial derivative of f with respect to z, we put it in the third component. Then it means that del f is equal to 10y e to the power of 5x minus 6y x squared e to the power of minus 3z. The second component is going to be 2e to the power of 5x minus 2x cubed e to the power of minus 3z. And finally 6x cubed y e to the power of minus 3z. So this is going to be the final answer to this question. Thank you very much for your attention. If you have any questions or if you have any doubts about any part of this solution, please let me know in the comments. I will answer them as soon as possible. Have a good day and bye.